Well, hello guys, here Mr. G with another video. This time we're going to be solving a question on electrochemistry for the grade 12s. This was question 8 done in the Eastern Cape in 2023 and we're going to solve it. I'm going to leave the question in the description below so you can answer the question before watching the video. But don't forget to subscribe to the channel and like the video. The question says a galvanic cell is set up under standard condition. One cell consists of a silver plate and in aqueous solution of silver nitrate, while the other half cell consists of an inert platinum plate in an aqueous solution containing ion 2 plus and ion 3 plus, as shown in the simplified diagram below. So question 8.1, write down the energy change that takes place when the cell is in operation. And well guys, what we have to say that chemical energy is converted into electrical energy. If you say that, you'll get 2 marks. Is quite simple and easy mark. For this galvanic cell, write down the oxidation half reaction and the cell notation. Now, what we need to know here, real fast, the oxidation half reaction, the oxidation will happen at the anode. So this is important to know. The oxidation will happen at the anode, okay? All right, so to do that one, we're going to go to the table of standard notation, this one here, this table here, and we're going to use the B. We're going to start, or we want to use this B. Now, what we have in this cell, on one side we have silver, and on the other side we have ion 2 and ion 3, okay? So we are going to be looking here for those two. Here we found, let me see, we're looking for them there. It is ion 3 and ion 2 is here on this side. And we're looking for silver. Silver is at the bottom. Now, what we're going to do, we're going to make like a C in this way. Now, for this table, if this happens in this way, whatever is on top will be the anode. And whatever is at the bottom will be the cathode. This works only with this table. So for that specific reaction, the oxidation remember here happened the oxidation, The oxidation is at the anode, okay? So the oxidation half reaction for this specific question will be the one of the ion, and the reduction half reaction will be the one of the cathode. So how would write those two half reactions? Let's write it here real fast. For the anode, which is oxidation, all we have to say is Fe 2 plus, only one arrow is going into Fe 3 plus 1 electron. Alright, this one is the oxidation half reaction. What will be the reduction half reaction? They don't ask, but it could be. It could be asked. So we're working now from left to right. It will be Ag plus 1 electron will give you Ag. This one is the reduction half reaction. Okay, so using this table, you always, the one that is on top, you write it from right to left, and the one that is on the bottom from left to right, to know which one is the anode and the cathode. It's quite simple. Therefore, here the oxidation half reaction which happened at the anode, and we did already write it, will be Fe 2 plus, Fe 3 plus 1 electron. This one is the oxidation half reaction. This is happening at the anode. Okay, it's quite simple, guys. The table have the answers for you, and if you do that, you'll get 2 marks. Now, cell notation. What I want to remember about cell notation. In the cell notation, you will always start with the cathode, then you go to the solution, then salt bridge, solution, and anode. So we're going for this one, we're going to do the same as we did now with the half reactions. We are going to use what we know in the table, and we're going to write it the other way around. from a cathode to anode. Alright, so if we go back here, no, I went too far. Here, we are going to now write it the other way around. So first, for example, it's going to be Ag, one line, Ag plus, there we go, then salt bridge, then on top you're starting with Fe, 3 plus. Now, in this case, platinum must be the cathode actually, so it's comma here, Fe2 plus, large platinum, which is Pt, and that is the half cell, the cell notation, pardon. So the cell notation, you come here, and we're going to write it in that way. It's not that difficult. Let's do it here at the bottom. This one is question 8.2.2. So we're starting, we say with the silver. So it's silver, it's Ag, which is the cathode. It is the cathode. We always start with the cathode. Ag, one line, Ag plus. Now salt bridge. Then it's the Fe in the same order that it is there in the table. Fe3 plus, let's fix this 3 plus here, 3 plus, comma, Fe2 plus, one line, Pt. This one is the cell notation. And let me tell you something, it's very easy to get marks here, guys. This line here will get 1 mark, the salt bridge will have another mark, and then the rest have another mark. It's 3 marks for that easy question. Question 8.2.3, write down 2 standard conditions for the Fe3 plus half cell. So for this half cell, which is the anode. Okay, so let's answer this question real fast here down. So what are the standard conditions? First of all, the concentration of the solution must be 1 mole per cubic decimeter. Nothing to say. The temperature must be 25 degrees Celsius. Now pressure is one of the conditions, but there is not gases here, so pressure is not applicable to that specific half cell. So this one is all you have to say. It's quite simple. Now remember, do not confuse this one with STP. These are standard conditions under which galvanic cell work. Alright, this is not STP. Let's write it here, no STP. Be careful with that one. So this we're speaking about standard condition is no STP. Okay, this is the standard condition for galvanic cell. Question 8.3, calculate the initial EMF of the cell. Now here the marks, guys, is 2 marks. It's nothing to say, 1 for each. Now to calculate the EMF, let's go back to the formulas once more. Here are the formulas, and guys, you do have to write the formula exactly as it is here. All those little words must be full there, otherwise you don't get the mark. Okay, so make sure you write either of them. All of them are the same. You'll get 1 mark for the formula. If you don't write all those words there, you do not get the marks. And this is question 8.3. Let's do it on this side here. I'm sure it's enough space. The E of the cell, and I'm going to write it exactly as it is there, is equal to the E of the cathode minus the E. Let's move it a little bit. I thought the space is going to be more than enough. It appears to not be more than enough. E of the anode. You write full complete word. And then, guys, all you have to do is to go to the table once more. The cathode and the anode. So we go into the table. Here we are the second table. Remember, use the second table. So for the anode we have 0.77. For the cathode we have, I cannot see that, 0.80. Okay, those are the numbers that we are going to substitute in this formula. Is quite simple. So cathode first, and cathode was 0.8 minus anode, which was 0.77. E of the cell is equal to 0.03 volts, and this is the answer. Another 4 easy marks, one for the formula which is given to you, one for the substitution of each of them, and one for the final answer. And we are almost done. Now they say, what would happen to the EMF calculated in 8.3 if a solution of NaCl were to be used as a salt bridge in the cell under standard condition? Write down only increase, decrease, or remain the same, and explain your answer to question 8.4. Now, this question could be tricky, but in this case, they are going to be using here, they say, in a salt bridge, to be used as a salt bridge, sodium chloride. So they use here sodium chloride now. All right? Now, what is actually happening? Let's remember in the cathode. So what is going to happen in the cathode here? This chlorine will move, some of the chlorines will move there, some Cl minus, and they will form a substance when they come with AgCl. This is a precipitate. Precipitate means it's solid, and therefore this half cell will stop working. So that is actually what is going to happen here. So we come in here to question 8.4 and 5, 8.4 and 8.5, both of them. So what we have to say, first of all, decreases. Now, why it does decreases? All right, there is always 1 mark for that. Now you have to say that the Cl minus from the sodium chloride would form an isolated salt or precipitate. It will form a salt. I'm going to write here precipitate. Remember, precipitate is a solid within a solution. Alright, precipitate is solid. Let's write it here. That is the meaning of precipitate. It forms a precipitate with silver, with Ag+. So it will form actually AgCl. This is the precipitate that is going to be formed in this specific point. All right. So now, what is going to happen? There will be not enough electrolyte, in the half cell. Not enough electrolyte in the half cell. There's only 2 marks for that. So you have to say for sure that a precipitate is formed. There is only 2 marks. One for saying decreases, 3 marks actually total. And the other mark is for all this, that a precipitate is formed. That is important. It's a tricky question, that one. The rest of the question is quite simple. But guys, thank you for watching. I hope it helped. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.